Right. Here in this chapter, we have already learned about what is computer. Computer is basically it's electronic system which we can use to feed data or raw or unorganized things and get it processed according to the instructions given by the users as software programs, and it will be then processed and producing information. So we can use that information for decision making purpose, and that is a system. So we learned that. And the specialty is it is faster, accurate, efficient, and it's versatile. That means it can do many different works, and it can store the things for later use, store and open. And also it is not getting tired. Then that is the sixth feature that we have discussed. And so we discussing about the classification of the computer. So we learned that there are three categories based on the size, four categories based on the size: supercomputers, large computers which are used by NASA, and large computers which are used by Google. So I think you have seen these things like Google server farms. Google server farm. Actually, it's a set of supercomputers connected together and create a large area. Right? Supercomputer can process multiple things, or it can process more data at a given time, because it can serve around several 100,000 people together simultaneously. Then how are we going to connect? Are we going to connect like keyboards and mouse to these computers and work? Or is there any other mechanism? What do you think? Are we going to connect keyboards and mouse and work with these machines, or are we using some other mechanism? What is the mechanism used? Can anyone tell? Yes? Ramidu, what is the way that we are going to use these computers? Are we going to connect them keyboards, mouse and work, or any other mechanism? Praveed? Timasha? In which way we are going to connect computers? Hope you can hear me, right? Vanshika? Okay, no response. Right, we are not going to connect machines. We are not going to connect computers. Right, we are not going to connect keyboards and mouse. So instead of what we are doing, we are connect these computers. We have to connect these computers to a network switch or internet. After connecting to the network switch or internet, then we can access. So these are our computers or terminals. Using terminals, we can access these supercomputers. Mainframe also the same. Supercomputers also the same. Those supercomputers are connected to the switch, and using the switches, maybe the switch is connected to internet. Then we access these supercomputer services via network. We are not going to connect keyboards and mouse directly, right? And the second large is the supercomputers, mainframe computer. It also serves several thousands of people simultaneously, and you can see the image. And the connection method is similar to the supercomputer connection method. And then the mainframe. So after the mainframe, there are mini computers. Sometimes nowadays these are called workstations. So this is used in gaming stations, maybe banks, universities. So like so in Sri Lanka, most of the time in universities they are using this workstation servers or servers like mini computers, not the mainframes and super. But some universities are using mainframes, but supercomputers I have not seen. Maybe they are using now, but it's rare, right? But these mini computers they are using in banks and all, maybe workstations, in gaming stations. For those computers also, multiple parties can connect and work through the network. And the next one is microcomputers. That is what we are using today. So mobile phones, desktop computers, laptop computers, all these are called microcomputers. So that is what we are using nowadays. And according to technology, I say according to technology, there are three types. According to size, four categories. According to technology, three types. What are the three types? Yes.
Analog computers, digital computers, hybrid computers.
Hybrid computers, yes. Analog, digital, and hybrid. Analog uses a continuous signal. A continuous signal. So things like pressure, speed, temperature, and speedometers, road lamps, meteorological processing. So we are using analog computers, but it's rare, right? It's rare. Scientific uses, we are using analog computers. Analog signal is a signal which has it has upper level and lower level. The signal can take any value between the upper level and the lower level, right? Signal can take any value between the upper level and the lower level. That is analog signal. Digital, it cannot take any value. So it can take defined value, right? So I think better you write down if you have not done. Analog means analog signals take any value between a given range. Digital signal will take, or digital signals will take given values, given or defined values between a given range. So that is the difference between analog signals and digital signals. You can draw this and show the difference of analog and digital. If you have not done, please draw this. Digital will take given values, analog will take any value. That's the difference. Hybrid computers will support both analog and digital. So based on technology, you have analog, digital, and hybrid computers. And also, we have a new category. What is that? Put asterisk and write, there is a new category too. That is biological computers. It uses engineered cells. Example, Xenobot. So those are not used in this analog digital kind of thing. It uses nerves, engineered cells. So it uses nerve signals. Xenobots. That is a new trend. Okay, please write down this quickly. Okay. So function of the computer system. Actually, we have already learned this previously, but in case if you cannot remember, so this is also called von Neumann diagram. Von Neumann diagram, that means whatever inputs will go to the main memory or random access memory. So in random access memory, you have instructions. So basically instructions are there in the hard disk or the secondary storage. But when it is executed, it will be loaded to the RAM. Normally, then instruction okkoma hard disk එකේ තමයි තියෙන්නේ, secondary storage. In hard disk, that is where we store our operating system. Operating system එක තියෙන්නේ hard disk එකේ, අනිත් software install කරලා තියෙන්නේ hard disk එකේ. Everything is there in the hard disk. But when we run, when we execute, when we open that, it will be loaded to the main memory. The word open කරා කියමුකෝ. Word open කරාම ඒක main memory එකට load වෙනවා. Word hard එකේ තියෙන එක main memory එකට. Then what happens when we type or when we input something? The instruction in the main memory, which is already loaded from the hard disk, will tell what to do. According to that, you have to send those instructions to the processor. Processor has few components. So one is arithmetic and logical unit, that is where the maths and logic happen. Control unit, that is like a traffic manager. It sends control signals to everyone. That is the place where everyone get controlled. Everyone is sent the control signal, and according to the control signals only, computer will work. Right, then the registers and cache memory. So what is cache memory? What is registers? What are registers? What is cache memory? Yes, I think you should know. Cache memory.
Memory in process.
Memory in the processor, we call cache memory. Registers, also memories in the processors. With these memories are called SRAM, static random access memories. Okay, then using these SRAM signals, so that is where the data stores in the processor until processed. And finally, it will be released back to the main memory, and main memory will release back to the output devices. If you want to save, it will be released to the secondary store. Then main memory is the busy place. It's sending, receiving all the instructions, sending, receiving data, taking the processed information, actually saving the processed information, and sending it to the output, obtaining the inputs, unprocessed information. Everything comes through the main memory. So main memory or the random access memory is very important component in your computer. Have you finished drawing this? I think we have done this in a previous day. Have we or not? If not, I can explain again, right? Don't worry. If you're saying no, we can't remember, I can explain again. What do you think? Can you remember this or can't? You have to decide, come on. Can you remember the processing happens inside the computer? This is called von Neumann diagram or the logical diagram of the computer system. Can you remember or can't? Silent means silence. Silence හැම වෙලේම පාඩුයි හරිද? සමහර තැන්වලදී silence හොඳයි. සමහර තැන්වලදී silence පාඩුයි. Silence වලදී මට ඕන දේ මම හිතාගත්තොත් එක්ක මම මේක explain කරගෙන යනවා. මට හිතුණොත් දැන් මේක තේරිලා කියලා. මතක නැත්තම් so yes, if you cannot remember, tell that you can't. So it's not a big thing. So then I can give, right? Okay, please write down the heading, logic diagram or block diagram of the computer. Logical diagram or block diagram of the computer. This is sometimes called von Neumann diagrams. Because that is suggested by a person called John von Neumann. He said that it is possible to store instructions. What von Neumann suggested. So better write down about him as well, because to respect. It is possible to keep instructions in the memory and then use on data to obtain information. Processed information. Earlier days, it is required to feed data and instructions repetitively. Earlier days, right? In earlier days, it was required, right? It was required to feed data and instructions repetitively. Even the task is repetitive. Let's say you want to type a Word document, but earlier days, you have to give the data and also you have to create the Word document, Word application, that time itself. Software එකත් ඒ වෙලාවෙම හදලා දෙන්න ඕනේ. Instructions ටිකත් ඒ වෙලාවෙම දීලා හරියට කේක් හදනවා. කේක් එකට අපි ඕන ingredients ටික දාලා කරන්න ඕන process එකත් එකින් එක දෙන්න ඕන. ingredients ටික දැම්මම cake එක එළියට එන්නේ නැහැනේ normally ingredient එහෙම තියෙනවා cake machines තියෙනවා pizza machines තියෙනවා ingredients දැම්මම pizza එක එළියට එනවා normally අපි ගෙදර හදද්දී බඩු ටික දාලා කරන්න ඕන දේවල් ටික කරන්නත් ඕන after that only the pizza comes or the cake comes outside but so what von Neumann suggested that no need to bake and no need to prepare the cake every time when ingredients are feeded when ingredients are given so we can create a machine which can remember all the instruction and it will automatically do the process and what you have to do is concern is give required data flour and then sugar you have to give that after that you can take the cake simple as that so that is what von Neumann suggested that is called stored program concept the concept is called stored program concept that means program is there in the hard disk that is let's say our word application එක අපේ hard එකේ තියෙනවා එතකොට word වලට data ආවම hard එකෙන් word අරගෙන ඒ data ඕන විදිහට හදලා අපිට print out එකක් ගහලා දෙන්න පුළුවන් word අපි ආයේ මුලින් ඉඳන් ලියන්න ඕන නැහැ ඒක stored program එක store කරලා තියෙනවා according to that we can work that is called von Neumann architecture okay so let's write the steps of sorry let's draw the architecture right quickly let's draw this using fundamental chapter okay this shows the clear diagram and components it's okay to write that one but it has more information therefore I'm giving this one right please draw this I'll tell you I'll explain one by one right first of all please draw this right now you should know the meaning of each device and how these devices are working together right this is actually a logical model but this explains how these devices are working together okay when you input something for an example when you input let's say I'm going to input a letter here letter A okay when I input letter A this letter A is accepted by MS Word and it shows letter A in the stream but this is a big process the MS Word may letter A access karala stream එකේ පෙන්නනවා but that is a big process why right it has accepted means this is not saved ne save කරේ නැති ඉන්න මේක තියෙන්නේ main memory එකේ main memory has accepted that and not only accepted so it's feeding that to the secondary storage that word application which was there in the secondary storage that is also now in the main memory එතකොට ඒකටත් අරගෙන A අකුර විදියට පෙන්නනවා but to do that it has a big process why because if I zoom this letter A if I zoom this letter A okay let's use an application I'm going to use okay online application photosphere.com that is online editor so similar to Photoshop you also can use this and I'm opening the file from the computer okay let's open the one that I have taken this is letter A this is the one I have taken I'm converting this to a simple format by thresholding okay sorry by thresholding and let's zoom this and now you can see so what is here is it a letter or set of colored squares is it actually a letter or set of colored squares right? You can see black color and white color squares, but ordered properly, right? Pixels, we call pixels. Black color and white color dots, we call this as a pixel. These pixels are nicely ordered, and when we see from far away place, we can see this as letter A, but actually it was not letter A. It's a set of pixels. These are having white and black colors. Actually, in our screen also we have set of bulbs. Set of bulbs in the screen, horizontally and vertically we have set of bulbs. So we have to turn on and off bulbs according to these colors. We have to turn on and off bulbs according to these colors, and that is what done by the CPU. CPU will take these instructions from Word and also data which we have given. It will send to the processor. Processor will understand that with the help of ALU and CU. CU is controlling, sending everything. CU tama ape e akura accept karana palaweni upadesa denne. When I type this, CU tells, okay, take this input. Then CU tells, so what is there? So CU tells the secondary storage to load that to the load MS Word application, and to that please accept this. CU tells CPU, understand what is this. CU tells CPU, so draw in the screen. Draw in the screen as a matrix and show it to the user. That is CPU. Inside CPU, CU tells everything, and CPU, ALU, and other people are responding that. That is the big process happening inside the computer. So what is the task of ROM, read-only memory? What is the task of ROM? Task of RAM, main memory, task of RAM you understood, that is temporary storage. What is the task of ROM then? ROM එක මොනවද කරන්නේ? Okay, ROM keeps instructions given by the manufacturer. ROM එකේ තමා manufacturer දුන්න නිෂ්පාදකයා දුන්න instructions තියෙන්නේ. ROM එක තමා මේ ඔක්කොම connect කරලා ROM එකෙන් තමා කියන්නේ මෙයා තමා output, මෙයා තමා input, මෙයා තමා main memory, මෙයා තමා secondary, මෙයා තමා processing. Likewise, each one know because of ROM. Because of ROM only each hardware will understand or identify the other hardware components. That is, ROM has firmware stored by the manufacturer, and it does the recognizing part of other hardware. So this is very important. Please write down the abbreviations and the meanings of each unit. And I think we better write the explanation also. In future we have this, but now itself we can write the explanation, what happened in each component, we can write that right now itself. So basically I just need you to write about ROM. So you should know what is ROM, or the read-only memory, what it does. It's very important. And what is RAM and what it does. Okay, so this part is very important. That's why I'm asking you to write down this. So what is RAM and ROM? What is done by random access memory and read-only memory? Read-only memory is nothing. It's none other than it's a chip, right? Read-only memory is a chip. So similar to RAM, RAM is also a chip, but it is removable chip. But ROM is not removable, but still it is a chip. So this is not CD-ROM, right? CD, DVD, ROM nevi. Yeah? CD-ROM kya make it. CD-ROM drive is this. This is CD-ROM and this is CD-ROM drive. But this is not the ROM. ROM means, okay, this is the ROM chip. It's a chip in the motherboard. Special chip in the motherboard, you can see. It's a special chip in the motherboard. And it has a program called basic input and output system. You can see BIOS, basic input output system. It has a program called BIOS. And also it has basically the program stored by the manufacturer. BIOS is also a program stored by the manufacturer. right? It also has something, so that is called CMOS. That is also important. CMOS is another chip, right? It's in the chipset, right? CMOS, this is the CMOS chip. CMOS is another chip in the chipset, right? This is inside the main chipset. And there's a battery to keep this CMOS memory. The reason is, there's a battery to keep this CMOS memory. Battery ka kona? So why we need a battery to keep the CMOS memory? Because ROM is read-only. We can't save anything in the ROM. If we change any settings, the ROM make settings api venas karot, we need another device to save. To save that, we have CMOS chip, another chip. To keep that memory, we have small battery. This is 3-volt battery. And it is only, it will cost you around 1,200 rupees. Sorry, 1,020 rupees. Sorry, wrong. 120 rupees. Rupiah like a series cost. So, eken tama computer ke date time make hema api off kala tiyana velawata yanne. The reason is this battery. Okay, please understand these components, right? RAM is the main memory. It keeps the temporary instructions, whatever the given. It is removable, and it is also called dynamic RAM. That is our main memory. ROM is a special chip. It is in the motherboard. The instruction in the ROM written by the manufacturer. So one instruction is called BIOS, basic input output system. We learned that, right? Then to keep this BIOS and ROM, there's a supporting chip that is called CMOS. That is the supporting chip. To keep the memory of supporting chip, you have a battery to give the power. That's how you power up the CMOS. Okay, these components are important. Please write down this. Right? No need to write the Sinhala note. Let's write the English one. Okay, here you have some additional note, right? But let's discuss this first, then the lesson will be easy. If anything difficult, please ask, right? If anything difficult, please ask. Then I can explain.